Wait. Okay, we're on the next one. Let me refresh my video because my computer's messed up. There's a driver issue that makes my webcam really frustrating to use, and my mouth doesn't sync up with the video, so you'll just have to not look at my beautiful face. So I'll make my face smaller. And we'll start on episode 2 of the NeetCode journey, because I am a NEET. I do not have a job, and I'm trying to get into the programming sphere. And to do so, you have to face the necessary evil of LeetCode. So we're going to go through this next question on the whole entire thing, the roadmap provided by NeetCode. I'll bring it up on the screen right now. We have arrays and hashing. We did contains duplicate. So now I'm off to the races with valid anagram. I'm so excited to do this one, honestly, because I just get to build my knowledge and get a nice job. So I have not looked at the solution for this, but I'm just trying to teach through, or I'm just trying to learn through teaching. So we have our LeetCode question up in here, and we have our class solution with an object to better get, submit and process the solution, for every test case that LeetCode provides. And we have our function is anagram with the self that refers to the class solution, S and T, which are strings. I don't really know what this means because I haven't read the question yet. But when we read the question, we are given two strings, S and T, where we want to return true if T is an anagram of S, and false if it is not. That's a lot of pressure on one guy. Okay, so an anagram, what even is that? It's a word or a phrase formed by rearranging the letters of a word, of a different word or phrase, typically using all the original letters exactly once. So we have anagram and nagaram. That doesn't even sound like a real word. But our output is true because these are anagrams. And we have example 2, rat and car, false. So what this is telling me is that when we have the input of S being this, it doesn't even have to be a real word. It just has to be, T just has to be a string that is the same, that has the same letters as S. So I don't really know how to solve this off the top of my head. So I'm going to look at the solution and try to teach myself from that and kind of narrate each line of code as it would be written and thought of. So I'm looking. Okay, be patient. Skip this part of the video. I don't care if you're listening. So we have our solution. Basically, what we want to do first is we want to check if the length of S is the same as length T. So basically, what we're going to do is we can just look at S and T. If length of S... Damn, I'm allergic to this. And we have the length of T. And we know that if the strings are different sizes, then there's no way that they're going to be the same given the definition of an anagram. Because they all have, if it's the same length of the word, then it's an anagram. But if it's not, which is what we're checking for here, we know at the end of the day, it's never going to be an anagram. So we can return false, and this will break us out of the loop. Ugh. Oh my God, I dropped something. I got too excited with this LeetCode. But if we can get past this roadblock of bad inputs, then what we can do is we can create some counts arrays. I believe these are arrays. I'm looking at the solution. And when we look at these arrays, we have 1 and 2. I believe these are arrays. Is this the right initialization of an array? Let me ask ChatGPT. Is this how you initialize an array in Python? Oh, it's not arrays. So they're empty dictionaries. And we don't want arrays because, well, I guess, what are the advantages of dictionaries? My hunch is that, okay, I'm not going to look at this. I'm not going to look at the bottom. What my hunch is that dictionaries are hash maps. And, or I guess they're not hash maps or hash sets, because these hash sets that we looked at in the last NeetCode question, they can't have duplicates. Or no, they can't. Oh, can they have duplicates? Can hash maps have duplicates? Maybe. I don't think so, actually. But my hunch is that dictionaries are better for strings for some reason. Okay, so I was right. Dictionaries do use a hash table data structure. And unordered key value pairs. So this is kind of a confusing topic, unordered key value pairs, because it's really abstract, but basically it's like a direct access to whatever element you're trying to seek. Flexible and dynamic. Okay, different data types, that's good to know, because we're just doing characters here of ASCII characters. I don't know what the difference is, like letters versus numbers, but I'm just going to think about that. Keep that in mind. It's easy to read and write. Okay, yes, and we use these curly bracket notations. And we have some built-in methods. So when we go back to our dictionaries here, we have count S and count T as two dictionaries to make up each anagram or word that we are given in the definition. So now, what we want to do is simply loop through the size of our first given input, where we have a for loop of I, which is just any variable, in the range of length S. So the range part is important. The loop will break if we don't have range in there, because it needs to have a value going from 0 to whatever maximum, and our maximum is length S. So as we go through I, we can look at both of the dictionaries and both of the input strings and look at them in a way where we assign the dictionary to the value we are iterating through over each input. And then we can compare the two dictionaries together to tell if they are technically the same. So the way we do that is by taking count S, our empty dictionary at this point, because we'll just say in theory we're not looping through anything yet, and we're looking at the first value of the S string input. And what we're going to do is we look at this, we assign this dictionary item to 1 plus count s dot get si 0. So I don't really know what this means, so let's try to figure it out. We have count s, which is our empty dictionary at this point, and we have dot get, and we also have si and comma 0. So my guess is that we are looking at the dictionary value that we're iterating through with the loop, and we are seeing if there is anything in there, and we're adding it to 1 for some reason. So I actually don't know the answer to this, so I'm going to look for an explanation with ChatGPT. Explain this. So we'll ask for the explanation first, and then we will ask it to, we'll ask for the high level explanation first, and then we'll break down each constituent part of this line of code. Oh, it's already going to break down each constituent part of line of code for us. Thank you. But I'm not going to humanize ChatGPT because, that's bad for AI. Sorry if I will get evaporated from the face of the earth in like 5 years from the AI taking over, but we will see what happens. We have count s. Okay, we'll go through the each explanation of each part. So, as what we understood, or what we've explained already with count s, si, and 1 plus count s dot get si 0, we have a dictionary, right? Which is being used to store the count of each character of string s, which is this. So this is the ith character in the string s, which will be used as the key in the dictionary. Okay? So now we have count s dot get si 0. So the get method is called on the dictionary with the key. And if the key is in there, it will return the value associated with the key. Otherwise, it returns the default value specified as the second argument, which is 0 in this case. So we're using the dot get method to check if si is in there, and then using 0 as the return statement if it is not in there. So then what we will do is we will take this layer of abstraction in and zoom out a little bit with this 1 plus when we are looking at the bigger picture on the right side of the equal sign. And we have an expression that increments the current count of the character si by 1. If the character is not already in the dictionary, the count will be initialized to 1. So basically, we have dictionary items that will increase by 1 if it exists in the dictionary. So we have, say, a character. We could have 2, the value of 2, if there are 2 letters that are the same. So you can have duplicate values in a dictionary. So then from here, we can go to the next line where we assign the increment count back to the count s dictionary with the key si. So if the key is not present in the dictionary, it will be added. So basically, what we're doing here with this count si is we're checking if this key has an existing key pair with the .get si. And if it doesn't, then we return 0. But if it does, then we can add it to 1. Or we can add 1 to the number of iterations that exist within this count S key pair. So we're just counting we're counting the occurrence of every letter within a string, given what we have for this question. So we have anagram so we'll say if we had S here, basically what we're doing is for every value of the length of the string, so for 1, 2, 3, 4, 5, 6, 7 values of this string, we are counting the occurrence of all the letters of A. So we would have at the end of this a dictionary of key value pair of A, which would have 3 counts, N, which would have 1 count, G, which would have 1 count, R, which would have 1 count, and M, which would have 1 count. So we can take this same property and use it for the next argument of T, not argument, but the next string that we're trying to compare to string S, and simply create a dictionary list of all the key value pairs that exist within this string. So from here, we now have dictionary accounts that represent each of these strings. So all we have to do is return the result of comparing count S to count T. And if this is true, if the two dictionaries are the same because of the occurrence of all of the same letters in each of these dictionary values, then we know that it will be an anagram. So if this is true, we have an anagram. If it is false, then they're not the same. They have different letters, which makes sense when we look at example 2, which is rat, which has 2 of the same dictionary key value pairs in both of the inputs, but 1 letter difference. And if these are not completely the same, then we know that it is not an anagram. So that's awesome. I think we got it. And I know we got it because I just read through and taught the answer as if I didn't know what it was. Okay. So let's think back to, let's try to relate this to something else now to further solidify this concept in our minds about dictionaries and things like that. So when we're looking at valid anagram versus like contains duplicate, I'll pull up, they both use hash maps, but you can have, can hash sets, I need to get this straight in my mind. Can hash sets be contain duplicates? How are they different from dictionaries? Okay, so they're both based on the hash table data structure, but they have different purposes and properties. Basically, hash sets are designed for storing unique elements, while dictionaries are designed for storing key value pairs. In a dictionary, each key is unique, but values can be duplicated. Hashes cannot have duplicates. So in a hash set, only the elements are stored, where in a dictionary, both keys and their associated values are stored. So a hash set, you can add or remove elements using the element itself, versus with a dictionary, you have a ability to access, modify, or remove the values based on the key, which is that extra layer of abstraction. So we have hash sets like this, where we use the set constructor. Dictionaries, we use the curly brackets or the dictionary constructor. And with our methods, hash sets and dictionaries have different methods for their specific use cases. We have add, remove, is subset. So we have hash sets for unique elements, while dictionaries for key value pairs. So then I just want to give myself more context here, and I want to say what would be some good instances where I can apply both. So we can apply both to the same problem. There are scenarios where both using hash sets and dictionaries can be helpful to solve different parts of a problem or to achieve different goals within the same application. Here are a few examples. So say we have a list of items and we want to find the unique item and their frequency in the list. So we can use a hash set to store the unique elements and a dictionary to store the counts of each unique element. So this is just an example of a hash set and a dictionary. So we have a hash set of these items, and we have the item counts here. Items is in this list. Unique items is this. So what we can do is we can use the hash set to simply give what is unique. It automatically gets rid of all of the duplicate elements, and then we can use item counts to set the iteration of, or the occurrences of these items in the list. So for example, like you're doing a grocery store inventory. That's what I see. So we have 3 apples, 2 bananas, and 1 orange. And say you want to change the thing, like somebody buys it, somebody steals a banana. I know I would, because I'm very hungry right now. I would do something to this to remove an item from the list and then update the hash map. Yeah, that would be accurate. But I could also edit either one with the constructors. It would just be different. If I was doing a hash set, I would use remove with the hash set, and then I would use the key value pair and subtracting 1 from the count if it were a dictionary. So that'll be this. We'll submit it, get 100%. It's like we're just throwing 3 and we no look submit, and we got that accepted question. So thank you for watching and learning with me on this episode of learning. We have our roadmap, and we can check another one off. We have valid anagram